Hi everyone. So I will be discussing uh, first, second, and third problem solution to the first, second, and third problem of Leetcode biweekly contest 81. So in this first problem, we are given a string is where every two consecutive vertical bars are grouped into a pair. So basically, for example, this and this bar are grouped into a pair, and here this and this, so these both are grouped into a pair. And also in the constraints it is given that there are even number of bars. Now we want to return the number of asterisks in S, uh, excluding the asterisk in between each pair of bars. So for example, in this case, uh, the uh, the first bar starts here and ends here, and the second uh, pair starts here and ends here. So now this now these two asterisks are in the first pair, and this asterisk in the second pair. So we won't be counting these three asterisks. So uh, the these two are the only asterisks which are not there in between any pair, so we would be returning 2. And in example 2 there is no asterisk, so we would simply return 0. In the third example, um, we have these two asterisks, and so this is one pair, this is second pair, and this is third pair, so none of the asterisks are in between any pair, so we would simply return the count, which is 5. So now so basically what I have done is that I've taken this between AST as false initially, and now in this C I am storing the count of the asterisks, and this is the I for iterating. So now I'm basically iterating through this string, and if this character is star or asterisk, so in that case basically I am checking if this star is between any pair. So if it is in between any pair, we cannot count those. So this is the first case, and otherwise we want to count and increase the counter. And also we have to make sure that um, we keep track of whether uh, we are basically um, we want to keep the track of the starting point of this bar. So now if this initially when this between AST is false, then in that case basically what I am doing is that if I obtain a bar, then I would change this variable to true. Otherwise, if I obtain if it is already true, then if I obtain a bar, then I will basically turn it to false. So if I explain it through dry run through this code now, initially I is here, and I is here, and C is 0, and this, let's say this is represented by B, which is false currently. For I is equals to 0, we'll check if it is this star or bar, which is not. So we would move this I to the next to here to the next position. Now here we have a bar. Now we would check if this b is false, which is false. So we would change it to true, which means that we have now entered this uh, in this bar zone. So um, now there is a star here. So in this for the star, I would check if this b is true, which is the case. So I would not increase the counter. Now I would move this to next. Now it is E, so we won't do anything. And now again, um, we get a star, but here it is B is true, so we'll just increase the counter. So again there is an E, we won't do anything. Again there is a T, we won't do anything. Now again there is a bar. So now there is a bar, and if this B is true, so we would change it to false again. Now this becomes false. Now again I move to C, and we won't do anything. So now there is a star. Now if in this star we would see if this B is true or false. B is false now, so we would increase the counter to 1. Then again there is a star, so again I would move the counter to 2, increase the counter to 2. Again I will there is a O, so we won't do anything. Now again there is a bar. Now B is false, so in this case change this to true. Now now this is true. Now again there is a star, so I would check if this B is true, which is the case, so I won't increase the counter. And then it goes to D, we won't do anything. It goes to E, we won't do anything. And then again there is a bar, so in that case I would change this to false. And then basically the loop ends, and we finally return C, which is 2. The time complexity of this problem is of length of S, where S is the input string, and space complexity is of 1, because I'm not using any extra space, just using variables like I and this between EST and C. So the space complexity is of 1. So now I will be discussing the second problem, which is count unreachable pairs of nodes in an undirected graph. So in this problem, we are given an integer n, and there is an undirected graph with n nodes, and we are given edges ai to bl. So, and we want to return the number of pairs of different nodes that are unreachable from each other. So, for example, in this case, we want to return the number of unreachable pairs. So the observation here is that so initially we have total nodes as 7. Now when we start DFS from this 0, we would traverse all these 4 nodes. So now we traversed 4 nodes, and um, the total nodes are 7. So the total left nodes would be 7 minus 4, which is 3. So 3 nodes are left. So it would simply be 12. And then now total, we can say total unvisited. Now we have visited these 4 nodes, so now we would subtract these 4 nodes from this 7, we would be left with 3. Now we start DFS from here. For this case, we would basically have only one visited node, and total nodes are 3, and we have visited one node only, so 3 minus 1, so we would have 2 here. Now total unvisited nodes are 2. Now we start DFS from here. We have so we visit 2 nodes if we start DFS from here, and the total are also 2, so we would subtract 2 by 2, which is this, so it would be 0. So total unreachable nodes are this 12 plus 2 plus 0, which is 14, which is also the answer. So this is the only observation uh, for this problem. This is the only observation required for this problem. Now I will explain um, what I am doing in this DFS code. So we have a visited array. So it is if so this is the boolean visited array. Now um, we start DFS from this 0th node. So for this example, we start DFS from this 0th node. So DFS of graph, right, represented by G, and this is source, and this is visited. So these three things are there in this DFS, and so now what I am doing is that uh, I am looking for neighbors. So neighbors of 0 here are 2 and 5. So neighbors of 0 are 2 and 5. Now I basically call for DFS of G comma 2 comma visited. Now again uh, now also after visiting 0 I would mark it as true and also 2 as true. Now neighbors of 2 are 0 and 4. So I would again call for DFS of G comma 0 comma visited, but uh, 0 is already visited here, so we don't want to do any computations for it, so we would simply return 0, and each call has a count with variable. So each call has a count with variable which tells the number of nodes we have visited for um, starting from that source. So now after this 0 thing, I would call for DFS of G comma 4 comma visited. Now for this 4, I would first mark it as true, then see the neighbors. 2 and 5 are the neighbors. Now again I would call for 2, DFS of G comma 2 comma visited, and again since 2 is already visited I would simply return 0. Also this has a count with variable. Now I would call for DFS of 5. So for 5 we have two neighbors 0 and 4, and count with is 0. Now DFS, this would again call DFS of G comma 0 comma visited, but since 0 is already visited we would return true. Similarly it would also call for DFS of G comma 0 comma 4 comma visited. It is also visited already, so we would return 0. Now uh, finally in this line I am basically returning the sum of count visited obtained from neighbors and adding this 1 for this 5. So it would be 0 plus 0 plus 1, which is 1. So from 5 I have visited 1 node. Now I return this 1, and then again from this part I have obtained 0, plus from this part I have obtained 1, and 1 from this part. So it would be 0 plus 1 plus 1, which is 2. Now again um, I would return 2. Now for this case uh, 0 is returned from here and 2 is returned from here and plus 1, so it would be 3. Now I would finally return 3 here. Now again 0 has done its computations for 2. Now it would try to visit 5 also. So 5 G comma 5, but 5 is already visited, so it would simply return 0. Now for this 0 we have 3 plus 0 plus 1 for this case, so it would be 4. Now we would finally return 4, which this 4 denotes that we have visited starting from the 0 we have visited all these 4 nodes. So and then what I am doing is that here I am doing this computation. So I would basically do 4 into 7 minus 4, which is 12, and adding it to answer. Then I would subtract this. So initially total unvisited is n. Total unvisited is n, which is 7. Now it would become 7 minus 4, which is 3. Again I would uh, now I would go to the next loop and start DFS from here, and uh, there would be a similar recursion diagram, but it would be shorter. So from that I would obtain 2. So I would simply multiply 2 and then 3 minus 2, which is 2 only, and then update to 1. Then I would start DFS from 3, and for that it would be 1 into 1 minus 1, which is 0, and I would simply sum all these, which is 12 plus 2 plus 0, and return 14. So this is the explanation to the second solution. So now I will be discussing the third problem, which is maximums or after operations. So this problem we are given nums, and in one operation we can select a non-negative integer x and in index I, and then we can update nums of I by nums of I and bitwise and with nums of i's or x. So and we want to obtain the maximum possible bitwise or of all elements after applying this update operation. So um, we don't even need to think about what this operation is um, trying to do. The only observation in this problem is that we want to count the number of so let's say here for this 3 the binary representation is 0110. For 2 the binary representation is 0010, and 4 0100, and for 6 it is 0110. Now the only observation here is that um, for all these cases we want to sum. Now one thing we know that if the if we have odd number of elements, so here for odd number of elements we have 1, which means that the XOR of these this first position would be 1. Similarly, um, the XOR of this position would also be 1. 2, 0, 4, and 6, and 3. Wait, so it would be 0, 0, 1, 1. So now again, so odd number of ones are here, so we simply know it would the XOR would be 1. Similarly, here also odd number of ones are there, we know it would be 1. Now in this position even number of ones are there, which means that the XOR would be 0 here. Now if we now the observation here is that even if this is even if there is an even count here, we would simply keep it as 1. The reason being that uh, we can basically either set this 4 to some other number, which let's say we can set 4 to 0, or we can set, as explained here, 6 to 2. Now if we change this 6 to 2, this one would not be here, so only one odd would be left. Now the second thing is that if there are the count of ones is 0, in those cases we simply put 0. We cannot do anything about those cases. So the observation here is that wherever there is even count greater than 0, basically wherever there is a count greater than 0 of these ones, we would simply have we would basically be assigning 1 to those positions. So this is what I have also done in the code. So initially I have converted all these um, integers to binary form. Then basically um, I am looping through these positions. So now I would loop for this 0th position, I would loop and count the number of ones, and for the second position, for third, and so on till the last position. And if the count is greater than 1, I would simply be assigning 1 to the output string, otherwise I would be assigning 0. So, and then after that I am basically converting this output string to integer. So for this case it would be 7. So this is the explanation to this problem. Now the time complexity in this case would simply be of n only, where n is nums dot length, and space complexity would be O of 1 or O of 32, which is also O of 1 only. So we can write it as O of 1 only. So these are this is the explanation to all the three problems of the Leetcode biweekly contest statement.